Lesson 106, Solving Radical Equations. I'm going to talk about this by using examples. If we have the square root of x equals 8 and we square both sides, we'll be able to solve for x. So x equals 64, and then we check by plugging in 64 to the original equation and make sure that it works out. For our second example, we have the square root of 2x equals 10. We do the same thing where we square both sides, divide by 2, and then we want to plug in the 50, so we have the square root of 2 times 50, or the square root of 100 equals 10, and that checks. On example 3, we have the square root of x plus 7 equals 11. We square both sides, and we get x plus 7 equals 121. Then we're going to subtract 7, and we get x equals 114. And if we add 7 to 114, we get 121, and the square root of 121 is 11. So that works. So it's good to check your work, make sure you have the right answers. Now if you have the square root of x divided by 3 plus 4 equals 5, if we square both sides, we're going to get x divided by 3 plus 4 equals 25. We want to subtract 4 and get x divided by 3 is 21. Then we times both sides by 3 and we get x equals 63. Example 5, we have the square root of x minus 6 equals 5. We want to get the square root term all by itself, so we're going to add 6 to both sides. And we get the square root of x equals 11. Square both sides, so x should be 121. Example 6, we have 4 square roots of x equals 24. We need to get that term, the square root, all by itself. So we're going to divide both sides by 4. The square root of x equals 6. Square both sides, x is going to be 36. One more example before we talk about extraneous solutions. The square root of x plus 6 equals the square root of 2x plus 4. So when we square both sides, we just get x plus 6 equals 2x plus 4. I'm going to subtract 4 from both sides, and I'm going to subtract x from both sides. So I get 2 equals x. And that's the solution. Now an extraneous solution, that's just a solution that doesn't work when you plug it back in to into the original problem. So it's a solution that doesn't work when plugged back in to the original. So here's an example. Square root of 7x plus 15 equals x plus 1. When we square both sides, we get 7x plus 15 equals x plus 1 squared. And remember, when you square a binomial, you're going to get a middle term. So we have 7x plus 15 equals x squared plus 2x plus 1. We're going to subtract 15 and 7x from both sides. We get 0 equals x squared minus 5x minus 14. Then we're going to factor. We want two numbers that multiply to get negative 14 and add to get negative 5. So that would be 7 and 2. So we get negative 7 and a plus 2. So that would be negative 14 and give us negative 5 when we add. So it's x minus 7, x plus 2. So we set each of those factors equal to 0 and solve. So x either equals 7 or x equals negative 2. So we plug back into the original equation. So we're doing our check here. we have the square root of 7 times 7 plus 15. Is that going to equal 7 plus 1, which is 8? So 49 plus 15, let's see, 49, 59, 64. And the square root of 64 equals 8, so that works. Then we'll try the negative 2, 7 times negative 2 plus 15. Does that equal negative 2 plus 1? So this is the square root of 1. Does that equal negative 1? No. So the extraneous solution is negative 2, and the only solution will be x equals 7. Now I'm going to do one more example. Example 9. Square root of x plus 6 equals negative 3. We get the square root symbol all by itself. Subtract 6. Square root of x equals negative 9. If we square both sides, we get x equals 81. When we plug it back in, we have the square root of 81 plus 6. Does that equal negative 3? No, it doesn't. It's going to be 15, not negative 3. So there is no solution. X equals 81 is not going to work, and we don't have any other solution to check. So there's going to be no solution. And that's the end of lesson 106.